In our last class, we started with the fundamentals of decision tree. When we have a data and we need to prepare a tree in order to make some decision. So we use one of the important supervised machine learning tool, that is decision trees. And basically when we have a lot of data set with number of features, then in some time we need to split the data according to the feature or the parameters. So if we are dealing with so many parameters, how to start constructing the decision tree, that part we briefly discussed in our previous class. In this particular lecture we will see some examples how decision tree is prepared, or if a data set is available with you, then how to calculate the entropy information gain, and how the most relevant parameters are taken into consideration for constructing the decision tree. So first of all we will see one example, and then we will start taking the problems. So in this particular table, you will see a data related to gender as well as the marks. So there are certain girl students and boy students are there, and their marks in a particular subject is given to you. So the question come in our mind, for this particular data set, if we want to construct a decision tree, then we can construct the decision tree according to gender. So the top node will be your gender, and the leaves will be of boys and girls. So that is one approach. But at the same time, we may have another approach, that is, we can prepare a decision tree for marks. So your node will be marks, and again we can construct a decision tree for the students who receive marks more than 50 and students who receive marks less than 50. So these are the two different approaches that we can use to construct a decision tree. But the important question is, which one is more appropriate, either first one or second one? This particular question come into picture, and in order to decide whether to go for first tree or second tree, the concept of entropy and information gain will help a lot. And last lecture we saw some examples, and today we will see 2 3 more examples. So let's take example number 1. Calculate the entropy of the following distribution, and the data is given to you, gender and the count is given to you. So just quickly I will tell you that we discussed in our previous class, the value of entropy should be as minimum as possible, and the in value of information gain should be at higher end in order to have a better uh, decision making. Okay, so in this particular case there are 9 male and 5 female are there. Now in order to prepare calculate the entropy for the given data set, first of all, we will calculate the probability of male, because total data set is 9 plus 5, which is 14. So total data points equal to 14. So the probability of male is 9 by 14. Similarly, there are 5 female candidate. So probability of female is 5 by 14. Then for calculating the entropy, we know the general formula. So generally E is denoted for entropy. So if you use different books, you may see different notations. So in order to understand it properly, we can use E. Then which is equal to minus summation I is equal to, in general case last value will be n, and here as there are only two parameters, male and female, these are the two features or parameters we can say, so we take n equal to 2 here, and probability of first parameter or feature multiplied by log to the base 10 probability of second parameter. So this particular equation we will be using for calculating the entropy. Now for the given data set, the entropy equation will be like this: minus into bracket probability of male multiplied by log to the base 2 probability of male plus probability of female multiplied by log to the base 2 probability of female. So this is just a expanded version. Now in this equation we already calculate probability of male and probability of female. So we will put those values into the equation, and when we put all these equations we will solve these equations, and upon simplification you will get the entropy for male candidate as minus 0.53 and entropy for female candidate is minus zero point 0.4, and the overall entropy E is equal to 2.93. So for the given a data set of male 9 candidate and female 5 candidate, the entropy for the distribution is 0.93. So this is how we use the given data. We calculate the probability of the features, then we use the entropy formula, we put all the values in that equation, and upon simplification you will get the value of entropy. Now we will go ahead. Now in example number 1 there are only two features, male female, and again there are two parameters, count, gender and count. Now let's take another example where again you need to calculate entropy for the following distribution, and here fruit color, test and count is given to you. So here total three parameters are there, and again in fruit color there are total four features: yellow, red, green and orange. And in case of test you have two features, one is sweet and other is sour, right? And corresponding count is also given to you. So as this is for understanding purpose, so what we are assuming here, we are not constructing a decision tree. In next example we will construct a decision tree, but here as we have to just calculate the entropy, so we will assume that the target entropy calculation is on the basis of color. So we are just considering the fruit color for calculating the entropy, and the test parameter we are not calculating, but we are taking into consideration while normalizing the things. So first color, as we decided to calculate the entropy for the color, so first is yellow color. So total count is 10 and total count of all the colors is 35. So the probability of yellow is 10 divided by 35. Similarly, the probability of red is, red count is 5 divided by total data point 35. Probability of green is 15 green color fruit divided by 35. Then probability of orange is 5, that is count for orange color, and divided by 35. So for each color we estimate its probability of occurrence. Similarly, For test also we have two features, sweet and sour. So in case of sweet, total data points is 15. So 15 divided by total number of data points 35. Similarly, in case of sour, the total sour data point is 20. So 20 divided by total number of data points 35. So in first step, as we discussed in previous examples, we calculate the probability of each feature. Then we go for calculating the entropy, and as we decided, we will calculate the target entropy, or entropy will calculate based on the color only. Okay, so as there are four colors, so four features are there, so the formula for entropy is modified as minus summation I is equal to 1 to 4, and probability of occurrence of a feature multiplied by log to the base 2 probability of that feature. And when you simplify this equation, you will get the entropy for yellow color, entropy for red color, entropy for green color, and entropy for orange color. Okay, in order to understand each calculation separately, I use different colors. So again, same formula I have put it here so that you will understand in a better way. Now this particular formula that we derive, we can solve it as well. For example, we can put probability of yellow, probability of red, probability of green, and we can calculate the entropy. But if we do this, then it will be simply considering the two columns. First one is fruit column and last one count column. But again, third parameter is also there, that is test. So that parameter we also need to consider and calculate the final entropy. So the sweet and sour, these are the parameters will be used for calculating the weight. So accordingly, we will consider the test parameter as well, and each of these entropies, so 1 2 3 4 entropies will be multiplied or weighted on the basis of test, and that will provide you the final entropy. So what we will do, we have entropy formula here that we normalize. So you can see here, so for yellow entropy we multiplied the corresponding test factor. For red entropy we multiplied corresponding factor. For green, corresponding entropy, and for orange as well. So this is how we need to provide weight to each entropy. You can see in the table, right? There are two colors of fruit for which taste is sweet, and when the fruit is green or orange, the taste is sour, that is acidic in nature. So whatever probability we estimated for sweet as well as sour, that we will multiply, so that we will get the weighted entropies, and that will be the better or we would say final entropy for the distribution. Now we will put those values. In previous slide we calculate all these values. So probability of test, so for sweet it is 15 by 35, probability of yellow is 10 by 35 multiplied by log to the base 10, probability of yellow is 10 by 35. Similarly for red color, the test is sweet, so probability of test is 15 by 35 multiplied by probability of red 5 by 35 and multiplied by log to the base 2 probability of red, that is 5 by 35. Similarly, we will put the corresponding values for green color fruits multiplied by corresponding weight of the sour test, and similar process we will adopt for the orange color fruit as well, and we will simplify the same. So for yellow color we get entropy value as minus 0.22. For red color it is 0.17. For green it is zero point 0.3. For orange color it is 0.23. Now upon simplification the final entropy for the given data set is 0.92. So this is another example where when more than two parameters are there, how we calculate the entropy. So the critical question is, in this particular example, we assume that the entropy will be calculated for the fruit color. But you may think that the entropy can be calculated for test and the weight factor of fruit color will be multiplied to it in order to normalize it. So that would be your decision. But in this example, we decided to calculate the entropy based on fruit color, and we will weight or multiply the weight factor of test, and based on that we calculate the entropy. So if there are more than three parameters, let's assume, let's say size. So again you can take some random values and you can also calculate the entropy values. So this is second example. Now we will go ahead. Yeah, one more thing. Whatever entropy we calculate and normalize for test, so that probability of test is also called as conditional probability. Okay. In previous semester we discussed what is conditional probability. Now we will go to our third example, because in previous two examples we understood how to calculate entropy. We also have understanding about information gain, and now we will see how we can make use of it to decide the decision tree. So which attribute would you choose to split the following data set into decision tree? So that split decision we have to make. Again, the data set consists of gender and the marks in a particular course is given. So when we look at the gender row, girls are also there, boys are also there. And again, marks, it varies from minimum value to some maximum value. Now, when we look at the data points, we can see that total 11 data points are there. Again, in the gender row, total 5 girl students are there and 6 boys are there. Furthermore, if we set a cutoff of 50 marks, then there are 7 students who received less than 50 marks, and there are 4 students who received more than 50 marks. So we have to make a decision. We saw in the first slide that should we construct a decision tree based on gender, or should we construct a decision tree based on marks? And here for our understanding we took a cutoff mark as 50 because it was not mentioned in the problem. It is up to you. Now, as I mentioned, we have to find out which of these two, that is gender or marks, is better for splitting the data set. You are free to make a two different decision tree, but we always prefer a better one. So we will take first scenario and we will try to construct a decision tree based on gender and the data will be split. So this is a typical decision tree we can make for the given data. So the top node is gender where 11 candidates are there, or number of data points are 11, out of which boys are 6 and girls are 5. So you can just count it this from the table and you can put those number in the decision tree. Now, the value of entropy and information gain will help us to make the decision. So, we will find out the entropy and information gain for this particular scenario where we want to know what is the entropy and information gain for splitting based on gender. So, as there are 6 boys and total 11 data points are there, so probability of boys is 6 by 11. Probability of girls equal to 5 divided by 11. 5 girls divided by total data points. Then entropy for the gender, because we considered as top node as a gender, so entropy for the gender is minus into bracket probability of boys multiplied by log to the base 2 probability of boys, and similar equation is for girls as well. So the first part will give you the entropy for the boys and the second part will give you the entropy for the girls. And probability of boys is 6 by 11, then again log to the base 10 2 6 by 11. Probability of girls is 5 by 11 multiplied by log to the base 2 5 by 11. And when you simplify it, you will get entropy for boys is minus 0.48 and for girls it is 0.52. And the total entropy for scenario number 1, that is when we decide to split the data based on gender, then the top node entropy is 1. Similarly, we need to find out the entropy for boys as well as girls as well. So in previous slide we saw that for top node we got gender equality as 1. Now when we split the data into boys and girls, then in that case we need to calculate the its individual entropy as well, because previously whatever we calculated, it was a joint case, because the gender has both girls and boys, so that's why we calculate the mixed type of entropy. Now at individual level, when we talk about only boys, so entropy for boys is equal to minus into bracket probability of boys multiplied by log to the base 2 probability of boys. So there are total 6 boys and number of data points are also 6 and multiplied by log to the base 2 6 by 6, because here we are talking only about boys, this particular box we are talking, and that's why we get entropy as 0. However, in previous case why we got 11, because the gender is 11, count is 11, but again it has two sub parameters, boys and girls, so that's why we got mixed entropy as 1. Now when we talk about girls, then the entropy for the girls is minus probability of girls multiplied by log to the base 2 probability of girls. We put the values Number of girls 5, number of data points 5, multiplied by log to the base 2, 5 by 5, answer is 0. So this is the individual probability. And now we have, just a minute. Yes, we have entropy for the gender. We have individual entropy for boys as well girl. So we will calculate the weighted entropy because we need to assign some weight to the boys as well as weight to the girls in order to calculate the total entropy. So weighted entropy for the child node is 6 by 11 multiplied by entropy of boys plus 5 by 11 multiplied by entropy for the girls. And as the entropy for boys and girls equal to 0, so weighted entropy for the child node is 0. Why we are calling here child node? Because whatever top node we get, which is called as parent node, and whatever nodes available at the lower end, we call it as a child node. So sometime instead of boys, girls and gender, we can call the top node as a parent node and the lower level nodes as child node. So weighted entropy we got as a 0. Therefore information gain, so once we calculate the entropy, we can calculate the information gain. So information gain for the gender is entropy for the gender, that we calculated as 1, and minus sum of individual entropies for child node. So in our case, entropy for boys and entropy for girls, these are the child nodes, and their sum is 0. So 1 minus 0, answer is 1. So information gain is 1 in this particular case. So we get a good value. So as the information gain value is 1, means, or it indicates that after split, pure set of boys and girls are formed and the splitting on gender makes a sense. So it is a good approach because as we generally say that the value of information gain should be at higher end. So we got a good value. So there is a good sense. But this particular decision tree is one approach. We have another approach based on marks. So for that also we need to find out the value of information gain and gender entropy. So we will go there. So the second scenario is constructing a decision tree based on, sorry, here it's not a gender, it's a marks. So make this note. So when we consider mark as a basis of the decision tree, so we put a cutoff of 50 marks. So the parent node is marks 11 data points. Students with greater than 50 marks, so 4 students are there, again in that 3 boys 1 girl is there, and students who received less than 50 marks, so there are 7 students out of which 3 boys are there and 4 girls are there. So again here in this cutoff also there are also sub nodes, or we can say leaves. So when we split it, we need to calculate its entropy. So before that we calculate the probability of boys with greater than 50 marks. So here 3 boys are there and total number of students with greater than 50 marks is 4. So 3 by 4. Similarly, probability of girls with greater than 50 marks. So number of girls are 1 divided by total number 4. So this is the probability for boys with marks greater than 50 and girls with mark greater than 50. Similar is the case with the other block, where we can try to calculate the probability that boys will get less than 50 marks. So 3 boys and number of data points 7. Similarly, probability that girls will receive marks less than 50. So number of girls 4 and number of data points 7. So 4 by 7. So this is how for after split we calculate the probability. Now we will go for estimating the entropy. So entropy when marks are greater than 50. So this is the equation for it. First part is related to boys with greater than 50 marks, and second part of this equation is related to the probability of girls having receiving marks greater than 50. So with this equation, this is the equation for calculating entropy. We will put those values. So probability of mark boys with greater than 50, 3 by 4 log to the base 10, log to the base 2, and probability of boys with marks greater than 50 is 3 by 4. Similarly, we will put other values in the equation, and when we simplify, we get the entropy for the marks greater than 50 as 0.81. Similarly, we can use a similar kind of formula for second box to know the entropy for marks less than 50. So this particular estimation is for marks less than 50, and we already discussed how to calculate the entropy when marks are greater than 50. So put all these values in the equation because we have respective values, and when you simplify it you will get entropy as 0.98. So see here, after split for first child node we got entropy as 0.81, and for second child node we got entropy as 0.98. Now we need to calculate the weighted entropy as well. So weighted entropy for the child node is 4 by 11 multiplied by entropy when marks are greater than 50 plus 7 by 11 multiplied by entropy when marks are less than 50. So where that 4 by 11 and 7 by 11 come? So in previous slide it is there. 4 divided by 11 and 7 divided by 11. Then weighted entropy for the child node, and it is simplified by putting the values 0.81. Here we will put 0.98, and when you simplify you will get the weighted value as 0.91. So the child node is there, and therefore again in that there is a different features, so weighted value we received as 0.91. Now we will calculate the information gain. So when we talk about information gain for the marks, so it is equal to parent entropy minus weighted entropy of the child node. So previously we calculated parent entropy and we get it value as 1, Now, by calculating the child node when marks are greater than 50, less than 50, then we use the weighted value in order to normalize it, and we received the weighted entropy for the child node as 0.91. So 1 minus 0.91, we get answer as 0.09. So information gain for when we plan to go for splitting the decision tree based on mark is 0.09. So when we create a decision tree based on gender, we get its information gain value as 1, and when we go for a decision tree based on marks, we get its entropy value as 0.09. And as I mentioned you again and again that the information gain value, if it is higher side, the decision tree is better, or that split is better. Now when we compare these two values, we can easily say that information, it is better to go for splitting based on gender instead of marks. So here it is not a gender, it is a marks only. So the information gain on the splitting the data set by the gender is higher than the splitting by mark. Hence, it is suggested to split the given data set on the gender. So what I wanted to convey here is that when we have a lot of, here we are just talk about a very small data set. When we have a large data set where n number of parameters are there, gender is there, boys girls are there, transgender is there, again different subjects are there. So if such a large data set is there, for example take your class only, so in your class boys are there, girls are also there, again you study around 5 courses in this particular semester. So each score they are also feature, again gender is also another feature or parameter, and for that we can create a decision tree in order to measure your performance. So you will have two options, whether to construct the decision tree based on gender or based on marks. Or again you may think that you can construct a decision tree based on your courses. That is also possible. So again for each case you need to find out its information gain. And if that for a for case we get higher value of information gain, that is the best way of splitting the data. So these are the three examples which will help you to construct a decision tree when you have different variables, and the value of entropy and information gain will provide you a strong foundation, which is the best method for splitting the data. So that's it from my side. If you have any question related to this particular session, you can ask.